Today I'm going to be talking about how to shard secrets and how to protect your Bitcoin, particularly your Bitcoin core. But we're going to have some best practices and lessons for how this should be working overall in the ecosystem, we'd hope. Chris has already talked a little bit about who Blockchain Commons is. Um, and as he said, this is drawn from work on the new learning Bitcoin from the command line that I've been doing this year. If you go and look there, it's at learningbitcoin.blockchaincommons.com. What I'm talking about today is basically a synopsis summary, top info from chapter 10, which is called Working with Secrets. And here's the link to the overall Learning Bitcoin course. It's something that Christopher and I have been developing since about 2017 or so, so it's had almost 10 years too. And every once in a while, we need to do a big update because Bitcoin is constantly changing. And so this is 3.0 that I've been working on since the start of the year. And as he said earlier, we've got most of it updated. And Taproot's the big addition that we still have. Okay, so today we're basically focusing on two themes, and the first of those is resilience. It's very important if you have self-sovereign control of your digital assets. Bad things are going to happen, and you don't want to lose your funds or digital identities or whatever else you're protecting with keys. And so that's what we're going to be talking about today. How do you protect your keys? But we're also going to look at the theme of interoperability. It's an important part of everything because it gives you independence. It lets you move your assets around as you see fit, and it also supports resilience. Without interoperability, you're probably not going to get to use these other resilient protective functions that you want to use. As we're going to see Bitcoin Core, we have to get things out of Bitcoin Core to offer the best resilience, and that requires interoperability. So they're really closely intertwined. And this is a very real need. Many of us have heard the story about the guy in Wales who sent a hard drive to the dump and realized it had what's now hundreds of millions of dollars in Bitcoin. It's not the only such story. I have a couple others here. Uh, in our opinion, when you're talking about self-sovereign control of your digital assets, when you are holding them on a hardware device or, in Bitcoin Core or something like this, and they're not in an exchange, the big problem you're going to have is loss. It's not theft. Doesn't mean that theft you have to not worry about at all, but loss is what you have to really keep the focus on. So our best practice to protect Bitcoin is to use multi-sigs. We have this whole scenario, which we have a QR for here, where you have two hardware devices, and then you print out the codes for a third key, and you shard those, and that way you always have yourself protected. You're on different devices, you're on different iOS operating systems. And it's a huge pain in the neck. We put it out there, and we know that not many people use it because it is real work, especially if you're not talking about huge amounts of funds. Um, so we need better solutions. And Shamir's secret sharing, it's our alternative. It has some issues that multi-sigs don't have. In particular, it lets you shard your key so that you can protect it. It lets you get your key back from a threshold of those shards shares that you've put out there. But when you reconstruct, it's very dangerous because you suddenly have your whole key in one place, and it may not be the regular place that's secure. So it could be stolen then, but we've already said that we think losing your key is much more dangerous than having your key stolen. So that's why we suggest Shamir's secret sharing if you're not going to use multi-sigs. So going back to Bitcoin Core, we saw that the first problem with keeping your digital assets safe was that um, you you can lose your key. And the second is that there are resilience features, but Bitcoin Core doesn't necessarily protect them. And um, we're talking about Bitcoin Core here because we've done work there. We offer it as a great way to learn about it, and we know some people use it as their wallet. But there's going to be other wallets out there that don't use resilience features either. So in particular with Bitcoin Core, there's two factors. There's the fact that it doesn't support BIP39 mnemonics or entropy. So BIP39, that's where you have mnemonic words, usually a set of 12 words that lets you reconstruct your seed. And it turns out that it's the whole kind of first stage that you can use to uh, produce keys. And Bitcoin Core skips it entirely. And the other thing is Bitcoin Core, like many wallets, doesn't have any access to Shamir's secret sharing. So the only way to really be interoperable when you're using Bitcoin Core is to use their descriptors. They're a descriptor wallet. Um, and that's all kept natively on Bitcoin Core in an SQL file. It's a very specific format that they have. You can back it up, and you obviously want to back it up, but you're dependent on a file format that someone might not understand in 10 or 15 or 20 years. And you're also dependent on a singular database that isn't sharded, that could be stolen if people grab that one thing, or that could be lost if you lose that one thing. And so it doesn't have any of the advantages of secret sharing. So I mentioned that BIP39 is kind of the first stage, and so I wanted to lay out all of the stages of how keys are generated on most wallets. Most of the time, you generate entropy, and you turn that entropy into the mnemonics. It's 128 bits of entropy. It's checksum. It generates 12 mnemonic words. There's then a one-way hash, which uses a password stretching function that gets you to what's actually called a seed, which is the BIP32 definition. But the funny thing is, this entropy back here, that's what actually is used by the whole system, the whole interoperable Bitcoin ecosystem as seeds, not the BIP32. And so that causes a lot of confusion and is one of the reasons it becomes much more difficult for something like Bitcoin Core to share because no one else recognizes what that BIP32 seed is. Then again, there's another hashing function, and it goes into the actual keys here, extended keys, chain code and irregular code, and then they're usually encoded in descriptors right now. So we can see that whole system, and then we can see what it looks like here in Bitcoin Core, which is the BIP39 is gone. The BIP32 actually is not accessible. It's never exported. And so when you're working on Bitcoin Core, what you have are these extended keys and more so descriptors. Descriptors are what you really have, but you can extract the extended keys from them, as we're going to see. So this is kind of our challenge. How do we correlate the extended ecosystem here, where we have everything, with Bitcoin Core, where we only have our descriptors and functionally our extended private keys? And that's what we're going to talk about today, how to get both in and out of Bitcoin Core. So here's our game plan. Bitcoin Core will allow us to export our master key, our descriptor. We can take advantage of that, and then we can secure those secrets with sharding once we've got them out. We also can go the opposite direction. We can create a seed externally and then shard it and simultaneously bring it into Bitcoin Core by converting it into an account descriptor. Both methods allow us to make Bitcoin Core assets much more resilient, which is, of course, our goal. In order to carry out this game plan, we're going to use a handful of reference tools that we've created at Blockchain Commons. Seed Tool CLI is a command line app that creates seeds. Key Tool CLI converts among a variety of cryptographic formats. And Envelope CLI is a smart document system for secure storage. And more than secure storage, very regularized storage. It's really part of the magic sauce of all of this. And SSKR, which we have here, it's our version of Shamir's secret sharing. It's integrated into these CLIs, and it does a little bit more than standard, as I'm going to talk about in a minute. Seed Tool and Envelope, they're both really easy to install Rust crates. Key Tool is a Python program. You have to clone it and compile it. Uh, it's available on the GitHub repo, and I've been working with it recently to make sure that the compilation's clean. And so there's instructions there that tell you how to do it all. If you've got Bitcoin to secure, you can just use these tools directly. More generally, though, we're offering best practices. We encourage developers to consider the interoperability that we're displaying here, to consider the tools we're displaying here, and hopefully take advantage of some of these same tools to offer interoperability for their own wallets. So our SSKR, which is our version of Shamir, it's a security reviewed library. It supports not just thresholds of people, which is what Shamir usually does, but also thresholds of groups, which each have met the criteria of a threshold of people. So you can say, for example, that we have to have at least 2 out of 3 people from 2 out of 3 groups, or something much more complex about that. When I talk about SSKR in this demo, I'm talking about this version of Shamir's secret sharing, but a wallet or someone else could easily use a different one, though ours is available in libraries and hopefully easy to add. So we're going to start out with the idea that you already have your assets within Bitcoin Core. And we're going to talk about how you would export these secrets that are actually exposed to you, and then how you'd back them up afterwards, since that's the point of getting them out of Bitcoin Core to make good, resilient, solid backups. So here's that game plan I showed earlier, hopefully actually readable now. It's really simple. We just either export a master key or a descriptor. I'm going to do both. We add metadata to it, and then we shard the envelope with Shamir's secret sharing. And like I said, the envelope and the fact that we can add metadata, that's a lot of the secret sauce here. It's relatively easy once you can figure out how everything works to get uh, the secrets in or out, but actually recording them in a way that you can come back to later, that's very important for resilience. All right, so I've screenshot a bunch of command lines beforehand, which hopefully will be clear and obvious here. So there are all of your coins in Bitcoin Core, they're protected by descriptor addresses. It's a descriptor-based wallet. And here we can see a listing that I've made of all of the descriptors in a brand new wallet that I set up. There are 8 of them, which is typical. Um, and They all include the master private key. It's the xpriv right here. And since it's the master private key, it's all the same private key. And you can see it's the private key because our derivation path here is all listed after the key. If this were a key that was derived lower down in the path, we'd have part of the derivation path at the start and part at the end. But the fact that it's all at the end tells us this is the master key. That's what we want. So this is just a bit of command line code that I've used to extract the various um, uh, descriptors into an array. Um, I've got all of this on a web page. I'm going to make it available after the meeting is over, but you can see I've just put all in, so I have it all accessible. And here I'm also using a bit more of command line code to actually extract the expriv out, the extended private key. So at this point, I have both the descriptors and the private key. I want to demonstrate how you might store the one or store the other. In real life, you'd probably only do one, but they're both valid targets. You might choose either. So we use Gordian Envelope to store things. It's a smart document system. It lets you record semantic triplets, subjects, and then assertions about them, where an assertion is a predicate and an object. You can see pred object here. Um, I'm creating an envelope where the subject is the master private key, and the assertions are all meant to describe it. What is it? What software created it? What software used it? What derivation paths are in use? The metadata is intended to help with the future recovery of the digital assets. It ensures that this key isn't just, a couple of digits on a piece of paper that no one might have any idea what are. So this shows it all much clearer than the instructions for how to create it. This is what a Guardian envelope looks like. You can see at the top, the subject, this is my private key. You can see I have an ISA that says it's a master key. Uh, you can see I have what created it, which I extracted from the precise version that I was using. And you can see that I also have what it's used by. And then I have my derivation paths so that I know all of the derivation paths that were being used. So this week, unfortunately, showed us exactly why we need to have that created by. It's because seed key creation can be buggy. And in an interoperable world like the one we are hoping to see more of, you can move your Bitcoin around, so you don't necessarily know where it originated unless you carefully record it like this. And Cold Card proved this last week why this is really important, but it's not the first case. Here I have another news headline from 2014 about blockchain info, where a white hat rescued a bunch of funds and then returned them, again because of a vulnerability in how they produce keys. And a few years after that, there was this big issue in JavaScript where secure random ended up not actually secure or random. And so that put a lot of things at risk. And so when we look at a cold card problem like this one, this is one of the ways that we solve it by actually saying, where did our seeds come from? The other way is multi-sigs, and again, that's not something many people are willing to do. This is a great start, though. Okay, so I showed you how we store a private key. This is the flip side, where we store a descriptor. And here's what this looks like in an envelope. I just gave this a subject of descriptors for Bitcoin as the subject. I said it was a collection of descriptors. Again, I showed where it was created, where it was used, and I listed all of the descriptors. So this is exactly what someone would need to restore all of these private keys and thus the accounts, addresses, etc., to Bitcoin Core. Um, and so that's the kind of thing that we want to see for restoring this in the future. So we want to shard these envelopes so that they're not just these private keys sitting on our hard drive. And we do that with envelope, which has SSKR built into it. We can see here just a couple of lines that shard them, and we drop them all in an array. And here is all of our shards in an array. And that's the first part of checking it works. And the second part of checking that it works is, can we actually restore it? And so here I use SSKR to put back two of the three shards because I had a two of three threshold. And I look at my restored envelope and I can see it is exactly like the original one. A best practice would be to test out restoration via all of the various means, i.e., I'd try share 0 and 1, 0 and 2, and 1 and 2, each of the combinations that should restore things, because before I put this off in storage, I want to make really sure I can get back to the original. So that is basically the methodology of how you start with Bitcoin Core, extract the important information, and store it in a resilient way that is also private and secure. So the opposite is importing a secret into Bitcoin Core. And in many ways, I like this one better because it allows you to start with an actual seed, technically BIP39 entropy, which is the standard of interoperability for the majority of the Bitcoin ecosystem. Um, and you can store that seed, you can shard it so that it's protected, and then you can use something to import into a Bitcoin Core, a descriptor as it happens. Here's the game plan here. It's a little more complex, and it comes in two parts. We use seed tool CLI to generate our seed. We store it in envelope CLI and shard it exactly as we showed when we exported something. And meanwhile, we use another tool that I talked about earlier, but we haven't seen yet, called Key Tool. And Key Tool is a magic little tool that imports and exports from, I don't know, 20, 30, 40 different cryptographic formats. And so it allows, among other things, us to turn that seed into the account descriptors that we're going to need. And those we're going to then import into Bitcoin Core. So here's how seed tool works. We type seed tool and it generates a seed. Um, and in this case, I demonstrate how it works and then I save that into a variable. And of course, the second one that I generated that I saved into the variable was different from the first because it generates a new one each time. That's why we keep it in a variable so that I'll have that static one that I'm using. Um, we're going to first do the import into Bitcoin Core here, and that's via Key Tool. And the way that Key Tool tends to work is you give it an input, in this case a seed, and you tell it what type of output you would like to see. So I'm going to need to generate 2 bits of information to be able to import into Bitcoin Core. Technically, I only need to generate one because this fingerprint you don't have to have, but it's a metadata, just like everything else. It'll tell us what seed this came from, and so it's important to have if you can get it. In this case, I'm just saving I'm just generating that fingerprint and I'm saving it to a variable. The other thing you need is an account key. I could choose to generate a master private key like the one we exported, but one of our general philosophies of architecture is what we call least necessary. We always want to give the least permissions, the least information, the least access that we can, are looking from the flip side, what's needed. And so we don't have to offer a master private key. We can offer an account key, and if just this one descriptor happens to be stolen in some way, it doesn't compromise all of the others. So here, again, key tool, we just feed in the seed and we tell it with this account derivation path, which is SegWit, we want to have the account key in base 58, which is the expriv format. Again, we save that. Then we create the descriptor. The way I make sure I understand the descriptor format is I usually go and I look at Bitcoin Core and I tell it to list descriptors and I make sure that the format is right. You can also go to the BIPs, of course, to get the format. In this case, we mark it as WPKH, so we know it's a witness public key hash. We put in the fingerprint and the derivation path that was used to generate the account key. Then we put in the account key and we tell it that it is an external address, which is 0, and that it is in a range of addresses. Um, you have to, when you're working with Bitcoin Core and working with descriptors, have a checksum. Fortunately, Bitcoin Core has a way to just use get descriptor info and you can generate a checksum. I use a program here called JQ, which lets you extract individual bits of data from JavaScript output. And I get the checksum from that. And then I put together my descriptor. And here's what it looks like. You can see there's the WPKH, there's the fingerprint, there's the derivation path, there is the actual private key, there's the rest of the derivation path, and there's my checksum. And that's what I'm going to need to import it. And importing is simple. I did create a new wallet here that did not have any private keys of its own, so I know anything in here is actually from the descriptor that I imported. And then I imported it with the first 100 addresses with all of the account information checked back to a specific time. And Bitcoin Core has told me it worked. And you always want to check your work again and again since you're working with self-sovereign uh, assets where you don't have backups. And then in this case, I list my descriptors and make sure that they're there. If I was working with a real wallet, I would import at least one more descriptor, which is I would import the internal addresses so that I could make change to my same descriptor address. But I might also want to import the other 6 that are standard. Legacy addresses, uh, pay to witness SH, and pay to taproot. So going back outside of Bitcoin Core, because I've already done all the work I needed to import, I also need to back this up. And here I wanted to show that Seed Tool actually can do backups on its own. Here I took my seed and I output it to BIP39 words. Those can be engraved in metal plates or output in some other very resilient form. And I can also just create straight SSKR shares from the seed tool. This is just the seed without metadata, which isn't necessarily as good. I mean, it's absolutely not as good. Um, and here, as usual, I check to put them together, and I should do this for all of them. And I can look and see, is this the same seed? It is. So I said it's not as good because, again, we'd much prefer to back up with envelope um, because we can put more metadata. So here, instead of the master key, I put in the seed and I say this is a seed. And again, I put extra metadata in. You know, I want to make sure I know it was created by Seed Tool and which version in case we ever have a problem. I want to know who it is used by so that I or someone in the future can go back and put this in and use the exact same software I was. And right now, I just have the one derivation path, so that's all I record. I might go back and expand it in the future. And once I have it in an envelope, I can shard it. There's actually a technical difference in between how seed tool shards and how envelope shards. Envelope creates a new secret. Uh, it shards that secret, and then that's what you get back to unlock the envelope, which has been cryptographically sealed with the secret, whereas the seed we're just sharding normally. But it's the same basic idea. It's all Shamir secret sharing. Okay, one other thing I wanted to mention, which is you've been seeing these URs, which are textual representations of the various codes. Um, they can actually all be stored as QR codes. In fact, UR was built so that it could very efficiently store itself as QR codes. Here is this seed, and here is this three sets of SSKR shares. Um, and these you can now store. There's things that allow you to print them in various ways. You could also send them to a friend if you're in person, by flashing them the QR and then them recording it in some type of QR storage software. One of the problems with QRs is the question of how you transmit them if you want to give them to someone further away over the net, which I think is very relevant for, say, SSKR shares. If I'm occasionally making these, occasionally updating them, I don't necessarily want to have to go out and visit every one of my friends, my attorney, whoever I have them stored with every time I do new shares. So the question arises, how do you safely secure these over the internet? And that, as it happens, is what Stan's going to talk about when he looks at Keylay for the second presentation. Okay, so I just wanted to show a couple more QRs. These ones lead to the tools. So if you want to go grab Seed Tool CLI, Key Tool CLI, and Envelope CLI, you can just click these QRs and they will open, I think our repo pages is how I set them to. JQ is the other tool that I did not link on here because it's available from jqlang.org. And it's also easy to install, say, on Debian. It's a package that you can install. But these are all of our tools. They're all available on GitHub at Blockchain Commons. The code is all open and open source, so you can look at them, you can review them before you use them.
I also put into chat the Seed Tool uh, iOS app, which does all of this with a nice UX and supports QRs, URs. You can test all of these different formats, and it can even sign air-gapped PSBTs.
Yeah, C-Tool iOS is very nice. And the only reason it's not used here is just because I'm showing how it all works on a command line to give a solid pipeline. But C-Tool is great. Once you have a seed, you can import it into C-Tool, among other ways, through QR codes. And then you can shard it from there exactly like we did on the command line, and then send those out as QRs. So that's my whole presentation. It looked at how to import and export secrets so that you can better secure your Bitcoin core. Are there any questions, comments? Alrighty, Chris, I will hand it back to you. One last QR here. That is chapter 10 of Learning Bitcoin, which goes over much of what I discussed here today in much greater length.